Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. And today, I'm going to talk about LangGraph framework. LangGraph framework is nothing but a multi-agent orchestration engine. In the last video that I did about LangChain agents, I showed you how agents can autonomously think and work through the available tools to achieve desired outcomes. Now, if you want some level of control on how to orchestrate different agents in a flow that is somewhat controlled by a human being through a programming logic, then that's where LangGraph framework comes into the picture. In this video, I will cover core concepts like state graph, what is node, what is an edge, and how the state that flows between the different nodes help achieves the desired outcomes. So with that said, let's dive right into it. Let's start to understand the concept of LangGraph through this diagram. LangGraph is nothing but a state graph that is composed of nodes, edges, and state. Nodes are nothing but the building blocks of your LangGraph. Each node can represent a function or a computational step. You define nodes to perform specific tasks such as processing inputs or making decisions or interacting with external APIs. Edges are the things that connect nodes with each other, essentially defining the flow of the computation. And state, you can imagine state as a container that holds the data. This is the data that is shared between the different nodes. So essentially, each node has access to the state and can receive the data from the state as well as update the data in the state. This is essentially useful when you're trying to orchestrate multiple agents to do specific tasks. Let's understand the nodes a little bit more in detail. What are the different types of nodes that are available? You have agentic node, you have a tool node, you have a human node, and then you have a conditional node. Agent node is when you have an agent which represents a node. So these are autonomous agents, LangChain agents, that you can specify specific prompts, specific tasks, and give them a repository of tools to work through the computation. Tool nodes are nothing but specific functions in terms of LangGraph. These are nothing but Python functions that are doing a specific task. Sometimes when you want to have a user input, a human input, you introduce a human node in the workflow where a human can either verify the results or accept or decline a certain step. And finally, we have conditional nodes. Conditional nodes are essentially nodes when you are trying to make a decision of a yes, no, or based on a certain criteria how to go from one node to another. You have conditional nodes. Let's understand edges a little bit more in depth. As I explained earlier, edges are what connects nodes with one another. We have different types of edges. We have a normal edge, essentially when the flow is very simple to go from computational step 1 to computational step 2, and it's a fixed flow. We use a normal edge. You have a start edge that represents the start of a workflow. You have an end edge which represents the end of the workflow. And finally, you have a conditional edge, which basically allows the flow of execution to follow different paths based on specific conditions. Instead of fixed operations, conditional edges introduce dynamic branches, making the workflows more intelligent and adaptive. Let's understand the LangGraph state flow through an animation. Essentially, we have 4 nodes: agentic node, a tool node, a human node, and a logic, and they all access the shared state. First, we define a state schema. This is our blueprint that defines what data structure all nodes will work with. Think of it as declaring basically schema keys like user query, tool results, conversation history, or any other schema data fields. Then the agentic node reads the current state and makes a decision and updates the state with its plan. Notice how the state grows with the new information. Then, the tool node sees the agent's plan in the shared state and executes the required function and adds its results back to the state. Every node benefits from the previous work. Finally, once the tool node is done, the human node can see all of the previous work done and provide additional input or approval or rejection. The state is preserved and the complete context of the conversation is also preserved. And finally, the conditional nodes are also there, which can help make smart routing decisions because they see the complete state. They see the original query, the tool results, the human input, and this is how you can enable the complex workflow logic. Finally, these different nodes can access the shared state at any time, and they use the reducer functions. They don't overwrite. Instead, you can append to lists, merge objects, or apply custom logic. This preserves the data integrity across the entire flow. And this is why LangGraph is powerful. Every node contributes to and benefits from the collective knowledge. Unlike isolated function calls, your AI workflow maintains the context and builds intelligence step by step. As you can see in this animation, all nodes have access to the shared state at all times and can read from and write to the shared state. Let's understand the conditional edges in LangGraph a bit more in depth. So as you can see, we have an entry node, which is where the workflow starts. Then we have a simple linear edge that goes from entry node to the assigned task node. And from there, it's another linear edge that goes from assigned task node to the process task node. Now, process task node is the node where there are certain criteria based on which it goes to specific nodes. For example, we have a status field inside a shared state object, and based on the match of that status field against a certain value, you go to a specific next node in the workflow. So for example, if the status is needs review, we go to the human review node. Once the human review is done, where they either provide the approval or give some more suggestions, it goes back to the process task. And then from there on, it makes another check on the status field. If the status is completed, we go to the success, but if status is failed, we retry the whole workflow. Now I want to explain the concept of LangGraph through a small code snippet. As you can see in this example, I have a graph state, which is nothing but a type dictionary. This is what's shared data structure that is shared between the different nodes. Then we have a couple of nodes. As you can see, these nodes take the input as the graph state instance, and they can read and write from that state. So we have a researcher node, we have a writer node, and essentially there is the concept of building the graph where it takes an instance of a state graph object, and then finally it adds node using the add_node API, and then it adds an edge connecting the two nodes. For example, I have a simple node, a simple edge that connects a researcher and a writer node using an add_edge API. And finally, you define which is the starting edge or which is the starting entry point using the start entry point API, and finally a set finish point API. And finally, you compile the graph using the workflow.compile. Now I want to go to another code snippet where I will explain how the conditional edges are created, but the concept is very similar. You have an agent state, which is nothing but a shared state that is used between the different nodes. We have different nodes over here: analyze query, search node, and knowledge node. As you can see, they all read and write from the same shared state, so nothing new over here. And then you have a conditional routing function, which is very important. This is the function that makes a decision to go from one node to another based on a certain condition. So for example, in this simple workflow, I'm parsing the needs_search field from the state, and based on that I'm making a decision whether to go to search node or the knowledge node. And if you want to see how the graph is constructed, let's look at it. The nodes are added simply. You have add_node API, which we saw in the last snippet. And then finally, to add the conditional edge, you have an add underscore conditional underscore edges API, where you specify what is the conditional node and then what is the routing decision between them. And then you specify the two nodes, for example the search node and the knowledge node. And finally the same, set entry point and the set finish points, and compile the graph, and you are good to go. So now we are towards the end of this video, and I wanted to keep this video really simple on purpose because I just wanted to introduce you to the core concepts of LangGraph. In a future video, I will show you a much more complex workflow where I have different agentic nodes and how the workflow flows between the different nodes because they share the state and update the state after their tasks are complete. Essentially, the goal of LangGraph is to bring a level of programming control or a level of human control in the flow so that the agents don't run autonomously and hallucinate. This is to find a good mix or a good balance between the autonomous nature of agents versus some level of static control that humans want to bring based on specific requirements of their application. So if you found the value in this content useful, please hit the subscribe button, and goodbye for now.